Hi guys, so in this video we'll be discussing about polymorphism. Okay, so this is very important topic to understand because polymorphism is one of the important concept which is most frequently asked in Java, especially for freshers interview, and moreover for experience also this has been asked. Okay, because there are a lot of concepts present within this polymorphism. So let's understand and dive deep into it. What's polymorphism actually, and what types of polymorphism exist in Java and how are they behaving in Java. Okay, so those all things we'll be discussing. So let's get started. So in this polymorphism, in the overview of OOPS concept, I have explained each and everything in overview, like what all OOPS concept means. Okay, so if you have not gone through this video, you might be seeing this here, just go through that. Okay, so then we will be discussing this polymorphism. So what is polymorphism now? Polymorphism is one entity, okay, which shows different behavior at different places throughout the program, that is called as polymorphism. Okay, so in layman language you can understand like a person. Okay, so a person behaves differently at different places. Okay, so you may be a person who is behaving a very professional manner in your working culture. Okay, but when you come to home, when you are talking with your parents or family members, you will not be that same person which you were in your office. Okay, and when you are going for party or when you are going to have a vacation, then that person, the same person will not be that you which you were when you were going to office or when you were talking with your family members. Okay, so that same person is you, but you are behaving differently at different places. That means we all are polymorphic in nature. We behave differently at different places. So this concept is called as polymorphism concept. Okay, so basically there are two types of polymorphism: compile time polymorphism and runtime polymorphism. Okay, so what are these? That we will understand now. So what is compile time polymorphism? So compile time polymorphism means it binds the method declaration and method definition at the compile time by the compiler. That is called as compile time polymorphism. Okay, so you can understand with method declaration and method definition, right? So method definition is the body part of the method. Okay, so you have written like public static void test and you are having certain method body. So you have written public static void test, that is declaration. Okay, and you are writing the body part. You are writing business logic for that method. So that is called as method definition part. Okay, so that combination of method declaration with method definition at the compile time, which is being done by the compiler, this whole process is called as compile time polymorphism. Okay, so I hope you have got the concept of compile time polymorphism. So now what is the best example for this compile time polymorphism to understand in Java? So best example for compile time polymorphism is method overloading. Okay, so for now, what is method overloading? So method overloading is nothing but a same method. Okay, that same method name, return type, everything is same. Okay, but the parameters present within this method, overloaded method, will vary. Okay, so it may have same number of parameters. Okay, it may have different variations of parameters. Okay, the order may change, the names may change. Okay, and the argument may change, but the method name will remain the same. Okay, so that is called as method overloading concept. Okay, so same, let's suppose I am taking an example of area. So if we want to calculate the area of certain object, so that area method name will remain the same. Okay, but the parameters will change. So let's suppose you want to calculate area of a square. Okay, so area of a square will take what? Will you give length and breadth both? No, it's not required, right? If you can give length, it's obvious that for square length is equal to breadth. So if you give only length, it will calculate me the area. So it will take only one parameter, which is length. But let's suppose you want to calculate the area of a rectangle. Okay, so what it will take? It will take two parameters. What it will take? Length as well as breadth. If you give only length, it will not be able to calculate the area of a rectangle. Okay, so for that you need to take same method name but two different parameters. Okay, two different parameters are required. Okay, so number of arguments gets increased, rather the method name remains the same. So that is called as overloaded method. Okay, so these are the things that we have to understand. Same you can understand with respect to cube and cuboid. Let's suppose you want to calculate the volume of a particular object. So one object is cube and another is cuboid. Okay, so for cube you just need to know one length. Okay, so that same length will be breadth also and the same length will be height also. So you don't need three parameters. Okay, but for cuboid, length, breadth and height all will vary. Okay, so for that you need three parameters. So method name will be same, volume, but the parameters, number of parameters or the arguments will vary. So that is also one of the example of method overloading. So we have understood a compile time polymorphism, like how we can how it is working, okay, and what's the best example and what is method overloading. Those are things we can understand. And in with respect to Java also, there are few examples for method overloading, okay. So one of the example is system.out.println, okay. So you can search it out, try to find it out why it is also called as overloaded method. So if you just try to find it out, you will say that it will take multiple parameters, okay. So these are the examples, and one more example in list, okay. In list.off there is one method called as off. So there also it will take multiple parameters. So that is also one of the overloaded method. So now next comes runtime polymorphism. So this is another part of a polymorphism, okay. So there are two parameters, okay, we have to understand. One is compile time, one is runtime. From the name itself you can understand, like runtime polymorphism is what? So runtime polymorphism is something where method declaration and method definition gets bounded at runtime by the JVM, which is Java Virtual Machine, okay. So Java Virtual Machine now comes into picture. It combines the method declaration with method definition at the runtime, okay. So now there is no compiler here. Compile time it's over. So now during the running phase, that time method declaration, method definition gets bounded together, okay. So that is called as runtime polymorphism, okay. So it is called as late binding. Runtime polymorphism is called as late binding, and compile time polymorphism is called as static binding, okay. So that is the difference, why it is called as late binding. So it is called as late binding because it's binded, the declaration and definition gets binded at runtime. So after all compilation process gets over and during the running phase, that time JVM binds method declaration with method definition. That's why it is called as a late binding, and it is called as eager binding or early binding. So this is the common important difference between these two. So now what is runtime polymorphism? So runtime polymorphism we have understood, where there is one same method declaration is present, method definition is present, okay. It is bounded at runtime by JVM. That is runtime polymorphism. So what is the best example for runtime polymorphism? For best example is method overriding, okay. So here it is method overloading for compile time, and for runtime it's method overriding. So what happens in method overriding? So in method overriding you can understand, like there is one class, okay, one super class, and there are several child classes which extends that super class. So that super class will be considered as a parent class, okay, and it has certain method, let's suppose test method, and there is few other classes like B, C, D which extends A class, okay. So what will happen? You will override that method into that class, into that child class, okay. So that is a inheritance, is a relationship which is happening here, okay. So now that is called as overriding concept, where you are overriding the method of the parent class, okay, and you are making changes into the business logic into the child class, okay. So I will show you with the example like how it is working, okay. So till now you might not be having any confusion. So it's method overriding is nothing. There should be inheritance relationship for method overriding to work. That is the concept we have to understand, okay. So wherever there is inheritance, there will be method overriding, okay. So inheritance, for inheritance what is required? There must be one parent class, there must be one child class, and there must be a relation between that parent and child class, and we have to override the method present in that parent class. So there this relation is present, then only we can understand method overriding, okay. So with the example of one bank we will understand how method overriding works over here. So what we will do here, we will take one bank, okay. So let's suppose in bank there are a lot of functionalities like deposit functionality, withdrawal functionalities, okay, like opening one savings scheme account, opening one pension account. There are a lot of functionalities present within bank, okay. So I'm not considering all those methods, I will consider in just one method. Let's suppose deposit method. A person came to deposit some money into that bank, okay. So that functionality I am taking into picture now. So what will happen? So all will have their different rate of interest, right? So let's suppose some person came to do FD in a bank, okay. So RBI has set a certain rate of interest that will be given to all the fixed deposit holders, okay. So all the investors were being given that, all investors will be given how much? Let's suppose I am printing here SOP 5%. RBI has default has given like 5% interest has to be given who are FD holders. Okay, but all banks will follow the same trend or not? No, right? You have seen like different banks has a different rate of interest. So those banks who are having attractive rate of interest, you will deposit your money in that bank only, right? If that bank is secured also and that bank is giving me higher rate of interest, so you will think of depositing your hard-earned money in that particular bank only, which is giving me more interest, right? So each and every bank is having their own rate of interest. Okay, so how can we implement that thing? So let's suppose I am implementing SBI. One class is there called as SBI. Okay, so that SBI extends bank. So this is the main class. Okay, this is the super class or a parent class. Bank is the parent class and SBI class is a child class of this bank parent class. Okay, and this SBI is extending this bank. So what will happen if it extends it? I will override this method, which is deposit method. I will override this method in SBI. So if I override, at the rate override needs to be given over here. Okay, and here I will add deposit method. Okay, and within deposit method, let's suppose SBI is giving me 6% interest. Okay, so SBI has extended this bank class and has changed the interest rate to 6%. So now RBI has given default rate 5%. Now SBI has changed it to 6%. So it is possible, right? Though there is not fixed thing like every bank will give same rate of interest. RBI has default given 1, but all the bank can change by overriding that functionality. So that is the concept. Third comes, let's suppose one more bank is there. Let's suppose ICICI Bank is there. Okay, ICICI Bank is extending this bank, and let's suppose ICICI is giving me 6.5% returns for FD. Okay, so two banks I am considering over here. So now which bank will you go for to open your bank account? Obviously ICICI Bank, because it gives me 6.5% return and SBI is giving me only 6% and RBI is offering only 5%. So you will definitely opt for ICICI because the bank is also good and is offering me more rate of interest for FD. Okay, so I will go for ICICI Bank. Okay, so this needs to be considered. So now we have to create one implementation class. Okay, this is the main class, bank class, okay, which should not be touched. These classes, child classes, will extend this parent class and will override the method and make changes, and then there will be implementation class. Okay, and that implementation class, what we have to do, we have to create the object of these child classes. So SBI is a child class, ICICI is a child class. So that child class's object needs to be created in one separate class. Let's suppose there is a bank functionality. I have created one class called as bank functionality. Okay, and that I have created a method called deposit function method. Okay, and within that I am passing a method called bank type. Okay, I am passing method which is of bank type. It's a main class. Okay, so I am creating bank type, which is a super class, and I am creating the reference here in this method. Okay, deposit bank method. And from the main method, what we have to do, from the main method I have to create the object of those classes. SBI Bank, ICICI Bank, however how many banks are there, you have to create the object of those banks. And then what we have to do, you have to create the object of this bank functionality, which is the implementation class. After creating the object of bank functionality implementation class, then you have to call this deposit functionality method, and you have to pass the ICICI Bank reference here. So then you will see that there is a upcasting happening. Okay, from main method you are passing ICICI Bank reference, but when you are calling this deposit bank functionality method of this bank functionality class, you will see that it is upcasting happened. ICICI Bank reference is upcasted to bank type reference. Okay, and within this functionality, what you are doing, you are calling this deposit method. Okay, deposit method of ICICI Bank. Okay, and as soon as you call the deposit method of ICICI Bank from this reference, you will be getting 6.5% rate of interest. So like this runtime polymorphism is working. So I hope you got the concept, you got the clarity like how all the classes are required and how it is getting interlinked with each other. Okay, so I will show you through code also. Okay, so it is just a brief overview I have given. So through code I will let you explain like how runtime polymorphism is working over here. So let's jump onto the code and check that. Hi guys, So we will continue with that compile time and runtime polymorphism code here. So here it's an example of compile time polymorphism. So here you can see I am calculating area of a square and area of a rectangle. Okay, so I have created overloaded method over here. So here you can see method name is same for both area of square, area of rectangle, same method name. Okay, so but it is overloaded. So here it is public static int area, public static int area, but parameters are varying. Square is taking only length, but rectangle is taking length as well as breadth. So here it is length multiplied by breadth. So here it is length multiplied by length only. So here you can see there is a variation which is a part of method overloading. Okay, so there are two more variations that it's a homework for you to do. Okay, so what are the variations? Like there are three variation: number of arguments, order of arguments, and data type of arguments. Okay, for overloading. So here it's an example of number of arguments is varying. So for you it's a homework to do when order of arguments and type of arguments are varying, so how overloading is happening. So order of argument means here if it is a comma b, so here it will be b comma a. So that is order is getting changed. So that is an also example of method overloading. Okay, and type of argument is getting changed. So it can happen like same method name but type is different, like one is int type, one is float type, and here is one int type and another is of string type. Okay, there may be a chance. So that way we are changing the type of arguments. Okay, so that is a homework for you. Second is runtime polymorphism. So here what is happening, I've created one class bank, okay, which is having their default rate of interest of 5%, which RBI has set. So SBI and ICICI I have taken. SBI is extending bank and it is changing its rate of interest to 6%. One is ICICI which is extending bank and it has changed it to 7%, let's suppose. Okay, so I have created one bank data. Okay, and it has one method discuss ROI. So here rate of interest is varying, so I have made one method discuss ROI, and here we are passing bank reference, this bank reference. Okay, so here we are printing, we are calling this rate of interest of different banks depending upon what is being called from the main method. So here if you see in main method what we are doing, we are calling the object of each and every banks. Okay, and we are creating object of the implementation bank class with bank data, and then with this implementation class reference we are calling this discuss ROI method and we are giving the reference over here. Okay, so here you can see what is happening here. So here what is happening here, method here upcasting is happening. Okay, so there are three parameters like inheritance, method overriding, and upcasting. So this is one of the thing which is happening. This is upcasting happening. So this is SBI reference which is upcasted to bank reference. Here it is ICICI reference which is upcasted to bank reference. So based upon the reference of the bank which is being passed, that particular rate of interest method will be called. So here it is SBI, so it will call SBI rate of interest method. Okay, so SBI rate of interest method is 6%, so this will be called first and then ICICI is called. So rate of interest for ICICI will be called the second, so 7% will be called the second. Okay, so if I run this code once, you will see the result. See, first ROI in SBI is 6% and ROI in ICICI is 7%. Okay, so like this it will be getting printed in the console. So like this compile time and runtime polymorphism is working. So I hope you got the concept, you got the clarity like how compile time and runtime polymorphism is working. So we have discussed in depth, and these only will be asked in interview, not much on this. Okay, so in the next video we will be seeing certain other OOPS concept. Till then, bye bye.